All right, so exponential, logistic, and logarithmic functions. Okay, so we're going to deal with those three types of functions today. Today we're going to start with exponential growth and decay. You did a lot of exponential growth and decay problems back when you were in Algebra 2. We're going to draw on some of that information. If you would like a refresher about your exponentials and logarithmics, we will put those on for this weekend to watch before your Monday, Tuesday class. Okay? So, without a calculator, sketch the graph of each exponential function. Identify the y-intercept and the horizontal asymptote of the graph. Use the tables to help make your sketch. All right? Well, we can do that. We can handle that. So, if I plug in -2 into this function, 2 raised to the -2 power is what? 1/4. Love it. So this function goes through the point -2, 1/4. If I plug in -1 into my function, 1/2. If I plug in 0 into my function, 2 to the 0 power, 1. If I plug 1 in, 2 to the first, 2. If I plug 2 in, 2 to the second, 4. So that function is going to end up looking like that. Okay? Drawing on your previous knowledge, is that a growth function or is that a decay function? Growth. Why growth? Because it's growing as our x's. So we always work left to right, and it's getting bigger as we go to the right. So that's a growth function. Okay. What is the y-intercept of this function? 0, 1 is my y-intercept. Where x is 0 is my y-intercept. Now, logic questions. We have a positive number to an exponent, and that exponent is what is changing. Can the value of that function, ever output, okay, so the value of the function, the output, can that ever be negative? Can I take a positive number to an exponent and get a negative value? No. Okay. Can I get 0 as an output? No. It's always going to be something. It may be really small, like if I put in -1 million in there, it's going to be really, really teeny tiny, okay? But it's still going to be something, and it's still going to be positive. So therefore, this function, this blue function, will never be negative, and it will never be 0. So y equals 0 would be a horizontal asymptote for it, because that function will never cross over. It'll get infinitely close to it, but it will never cross over it. Okay? Let's try number 2 now. Okay? We'll use our chart again. Okay? 2/3 to the -2 power. Agree? Because we don't like negative exponents, right? So we reciprocate the fraction, and that makes the exponent be positive. And then, so what is 3/2 squared? Three-halves squared. 3 squared is? 2 squared is? So 3/2 squared is? 9/4. 2/3 to the -1 power. 3/2. 2/3 to the 0 power. 1. 2/3 to the 1st power. 2/3. 2/3 squared. 4/9. Growth or decay? Why? Is what? Decreasing as we go to the right. Yep, we'll get to that one in a minute. Okay, so that's a decay. Y-intercept? 0, 1. Again, we have a positive number, right? 2/3 is positive. Raised to an exponent. Will that value ever be less than 1? Or excuse me, not less than 1. Less than 0. So will it ever be negative? No. Same logic we just used. Will it ever be 0? No. Same logic we just used. So y equals 0 is our horizontal asymptote. In Algebra 2 last year, we were able to identify exponential growth and decay based upon the value of b. So here is our parent function. Half of x equals a times b to the x. We identified with values of b, which made it growth and decay. So you guys have on your note sheets in front of you, you have it right above it. For me, it's on the other slide, so I'm not going to flip back and forth because I don't want somebody that's watching this online to, stroke out. Okay? So, when is this a growth function? When is an exponential a growth function? When the base is greater than 1? Okay. So my b here would have to be bigger than 1. Makes it a growth function. Can the base ever be 1? So can my base equal 1? Nope, can't do it. Okay. When is it a decay function then? When b is less than 1? Or less than 0? Or something else?
In between 0 and 1.
I like in between 0 and 1 because it can't be negative, right? Because if it's negative, then it'd be flip-flopping, positive and negative, and this was always a nice smooth curve. So this is between 0 and 1. And just like it can't be equal to 1, the base cannot be equal to 0. Okay? When we were making our charts on the top of the page there, what were the two easy exponent values? 1 and 0, or 0 and 1. So when our exponent is equal to 0, and when our exponent is equal to 1, those are the nice two key components. So we can utilize those two facts together in that we can say, if we know that it's a growth function, as we go to the right, it's going to go up. Okay? And then we can just figure out where those 2 points are and then fill in our graph. We don't have to do a 5 or a 7 or an 8 or however many points you need in a T-chart. We can just do 2, and more than likely you'll be able to do those in your head. Okay? All right? This next part, by the way, just so for you guys following along, it's actually in the middle of the next page. Okay? For the graphs of that form, the y-intercept of that graph, where is the y-intercept of this function? Y-intercept is a point. So I need something, comma, something. You know what I mean? I need two values. Okay? So, how do we find the y-intercept? We did it twice at the top of the page. The y-intercept is where x equals 0. Okay? So my y-intercept so I would have to plug in 0 in this function, right? I'd have to find f of 0. Well, b to the 0 power is what? 1. Anything to the 0 power is 1. Times a. 1 times a. A, right? Okay? So the value of this function is a when x is 0. So my y-intercept is at the point 0, comma a. And the horizontal asymptote, or the ha, if you will, okay, or the ha is at what? Y equals 0. Okay. For you guys in class, now we're going to go back to exploration. For those of you following along on the interwebs, now we're at the bottom of page 1. Okay. So since I know the basic shape of the parent function for a growth or decay, I only need to make a couple of points to make a pretty decent sketch. Okay. So for those of you here in class, you want to go 2 different colors now. We want to double our color output. Okay? Because we're going to do these 2 graphs on the same coordinate system. Okay? So, I will do the first one, example number 1, I will do in blue. Okay? So that's going to be my blue graph. What values, I want my exponent to be equal to 0 and I want my exponent to be equal to 1. So what values of x make my exponent 0 and make my exponent 1 in example number 1? What values of x make it 0 and what values of x make it 1? What? I'm looking for values of x that are going to make that exponent be 0 and be 1. It's a trick question. 0 and 1. because the exponent is just x. Okay? So I want x to be 0 and I want x to be 1. Well, then x has to be 0 and x has to be 1. Okay? You'll see what I mean when we get to example number 2 with why we have to ask that question. Okay? So if I put 0 into that function, 1/2 to the 0 power is 1 times 4 is 4. 1/2 to the first power is 1/2 times 4 is 2. So, rough sketch, 1, 2, 3, 4. Agree? Growth or decay? The decay. My y-intercept. 0, 4. My horizontal asymptote. Y equals 0. Okay. Next one now I will do in purple. Okay. What values of x are going to make my exponent be 0 and 1? -3 and -2. If I plug in -3, my exponent becomes 0. So 1/2 to the 0 power is 1 times 4 is 4. If my value of x is -2, my exponent is 1. -2 plus 3 is 1. 1/2 to the first power is 1/2 times 4 is 2. Is that a growth or a decay? Growth or decay? Decay. B is between 0 and 1. And it's the same as my blue one. Okay? Do I know where my y-intercept is? We can figure it out though, so let's wait on that one. Do I know what my horizontal asymptote is? What is it? Y equals 0. Okay? So now let's figure out what f of 0 is to figure out my y-intercept. So that's going to be 4 times 1/2 to the 0 plus 3 power. 0 plus 3 is 3. 1/2 to the third power is 1 too many. 1/8. Okay. 2 to the third is 8, so that's 1/8. 1/8 times 4 is 1/8 times 4. 1/2. So that gives me the point 0, 1/2. What does that C value, this C value right there, what does that C value do to my function? Which way? left and right. Okay, so C down. So C is the horizontal shift of f of x. Okay? Now, a couple of notes about it. It's one of those you gotta think opposite type things. Okay? Because on this one that we just did, we said that C was +3 in that C position. Okay? But we shifted left 3 from the blue. So if it's x plus C, that is a left shift C units. And if it's x minus C, that is a right shift C units. Okay? Let's talk D now in that one. So this is at the bottom, the last 3 on the bottom now of page number 2. Okay? So if that C value shifts stuff left and right, what do you think that D value is going to do? Up and down. Yep, that's going to shift it up and down. Okay? So it's going to take the entire graph and it's going to go up or down with it. Now that is a normal thinking type 1. Okay? So it's going to take the whole graph and the asymptote and adjust it to wherever it needs to go. So the horizontal asymptote gets shifted to the line y equals d on that particular graph. And we think normally. We don't think opposite on that one. So, number 7 here. First off, I like to start with my horizontal asymptote because that's going to tell me up or down where this one goes. Okay? So on this particular one, the horizontal asymptote got shifted up 1. So it's at y equals 1. Agree? Okay. If you need to make a little t-chart, we can, but we can also kind of do it in our brain too. 0 is the number that's going to get me 0 in the exponent, right? 4 to the 0 power is 1, plus 1 is 2, so this goes through the point 0, comma 2. 1 is the number in the exponent that's going to get me 1. 4 to the first power is 4, plus 1 is 5, so that's going to go here. So my function is going to go actually more than that, but here, let's go back down here, way up here. Makes a bigger curve than that. Okay? Oops, but now I overwrote the number. OCD kicking in. Where is the horizontal asymptote in number 8? -2 is a number. Horizontal asymptotes are lines. Y equals -2. Zero gets me 0, right? 0 gets me an exponent of 0. 1/2 to the 0 power is 1. Minus 2 is -1. One gets me 1. 1/2 to the first power is 1/2. Minus 2 is -1.5. Okay. Where is my horizontal asymptote in the next one? Number 9. Y equals +2. What value of x gets me 0 in the exponent? What value of x gives me 0 in the exponent? 1. Okay. So 1 minus 1 is 0. 1/4 to the 0 power is 1. Times 8 is 8. Plus 2 is 10. So I went through the point 1, comma 10. What value gives me 1 for an exponent? 2. 2 minus 1 is 1. 1/4 to the first power is 1/4. Times 8 is 2. Plus 2 is 4. Oops, I forgot to write down what aha was. On the first two, we found the y-intercepts. What is the y-intercept on the third one, on that last one? What is the y-intercept? Zero minus 1? 1/4 to the -1 power? 4 times 8? Plus 2. So the int here is 0, 34. Way up off the graph. Okay? Again, tomorrow if you are missing class because of the assembly, it is your responsibility to get caught up before Monday, Tuesday. And we will post a couple of videos from Khan Academy or Math by 5 or from somewhere about reviewing for exponentials.